Assalamu alaikum everyone. I hope you're doing well. So in this video we will go over a new topic. It's basically about routers and how to configure them, how to set connection or communication between two different routers, all of that. So let's get started. By the end of this unit or chapter, you will be able to do all of these. You will be able to understand the different functionalities, features, and configurations that can be done on a router. First of all, router has different components. All right, it has something called the CPU. Every device has a CPU. That's where the operations basically happen. Instructions are followed. Then there is RAM. Basically, the RAM on a router contains the configuration files, which is nothing but settings of the router, and it stores its routing tables and all of that. Again, we'll look at that in a minute, but remember that RAM content, whatever is stored on a RAM, it is lost when the power is off. So when you switch the router off, everything is lost. Okay, now the next thing is ROM. Like every other device, there is read-only memory. Again, this contains basically the diagnostic software, which is used when the software is running, not the software, when the router is running, and it also stores the router's bootstrap program. So basically, it stores the software that the router uses to run on, basically. The next one is non-volatile RAM, which is NVRAM. This one stores the startup configuration. So every time the router starts up, it uses this configuration file or the setting file to basically reboot or to start. Okay, this may include IP addresses. So the IP addresses that you assign to the to the interfaces or the ports, they are stored in the startup configuration, and other details like the host name, which is the name of the router, is stored. The routing protocol that is used, again, this is something we will look at in the upcoming lessons. But anything to do with the configurations or settings that need to be stored are stored on NVRAM, okay, in something called the startup configuration. Then we have flash memory, which basically contains the operating system of the router. And then lastly, we have interfaces. Interfaces, again, nothing but ports, okay? And there are many interfaces, not many, but there are multiple interfaces that are present on a router. Some of them have all these interfaces. Some of them have few of these. It depends. So one of them is Ethernet or fast Ethernet interfaces. The second one is serial, and then there is management interfaces. We will look at all of these in detail. Okay. Now, router interfaces. This is where we talk about the interfaces in detail. They are, okay, what is a router interface? A router interface is a physical connector that enables a router to send or receive packets. So all of these here, this one, which is an Ethernet, this one, which is an Ethernet again, this one, all of these are interfaces, okay? When you plug the cable into these interfaces, the router is able to then send and receive packets. If there is no cabling that is plugged in, that means the router is not connected or it's not on a network. It is just a useless device because you've not connected it. So as soon as you connect these ports through cable, you're able to send and receive packets, okay? That's where the communication happens. Each interface connects to a separate network. So basically this interface, if you plug in a cable, will connect to a different network. This one will connect to a different network. And if there are multiple other ports or interfaces, they will also connect to different or separate networks, okay? Now, what are the different types of interfaces? We just saw that there is Ethernet ports that are present on the router. There is fast Ethernet. Again, these are used for connecting either switches or hosts. Okay, so switches or hosts. Then you have your serial cable, which is used to connect routers. DSL, ISDN cable, all of these are for other connections, for modems and all of those. So when you connect a cable into these ports, okay, here, when you connect cables into these ports, you need to assign IP addresses to these. Okay, let's stop calling it ports. Anytime I say interface, it means ports. Okay, from now on, I'm going to use the word interface for the ports on a router. So for each of these interfaces, because they connect to separate networks, they have their own IP addresses and their own subnet mask. This is where you would assign the subnet mask and the IP address for each of the network. Okay. Now, router interfaces. There are two groups of interfaces on a router. There's one for LAN and there's another one for WAN. Okay. Now, LAN is used to connect router to a local area network. Okay. So basically, there's probably one router and then multiple switches. I'll just draw boxes for switches, and then these switches have their own hosts. Just write H for each of them. Okay, so this means this is a local network. Okay, so you have LAN interfaces which are used for local network, and they have layer 2 MAC addresses. Okay, now for each of these LAN interfaces, you can assign IP addresses. So if you notice, this area is for LAN interfaces, and for each of them, you can assign an IP address and subnet mask, and you would actually plug in an Ethernet cable there to basically connect the router in that port. WAN interfaces, on the other hand, use serial cable, okay, and they're used to connect routers to external networks, or in short, routers to routers. So serial ports are used to connect routers with different routers, which means if this router is one network and this one is another network, you're connecting inter-network devices, or you're connecting different networks together. Okay, and here also we assign IP addresses to the serial ports, and depending on the technology that you're using, you can also assign a layer 2 MAC address. So on layer 2, because we have switches on, if you remember, layer 2, sorry, I wanted to write layer 2, layer 1, and layer 3. Okay, so hubs, switch, and router, if you remember. Router uses IP addresses. If you remember from the last unit, switches use MAC, or they track MAC addresses, and hubs send nothing but digital signals. Not digital, but signals. Okay, so when you're connecting WAN interfaces together, you're basically setting IP addresses. Okay, and yeah, that's basically what is mentioned here. Okay, so when you basically design a network, you're supposed to provide all of these information in a document. What is it? You need to design and define the topology, which is nothing but the drawing. So this will be considered as a topology. Okay, you need to show the actual drawing of your network, and then the address table that provides the following information. Then you need to also provide a table that provides you with the name of the device, with the interface it is using, the IP address on that particular interface, the subnet mask on that particular interface, and the default gateway for that particular interface. For routers, we don't have default gateways. Okay, so it will always be NA, 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 NA. But for PCs, for other devices, for all the other devices, we have default gateways, and these are nothing but the address that you set on the router. So this is what you need to provide. Every time you design a network, you need to provide a drawing that shows your network in a diagram, and the table that shows the addressing details for that network. Okay. Basic router configuration. Now, these are some things that we usually always configure on a router for, let's say, best practices. The first one is the router name, so you can identify the router. Otherwise, every router will have the generic router, and then its number next to it. So 1, 2, 3, 4, 5. That makes it difficult to find or to locate routers, right? So the first thing you do is you give it a name, and this name is usually unique. So let's say you can name the router Manama. That can indicate that this is a Manama router or anything of that sort. Just give the router a name so you're able to identify it uniquely. Then there is banner, okay, which has nothing but a message. So you just display a message to the user to warn them. These are basically used for warnings. So let's say unauthorized use prohibited, or only accessible for the IT department, something like that. So this is just to display message or warnings on the router terminal. Then you can set passwords for different interfaces on the router. You can also set password for access to terminal, all of those things. And then specifically, you can configure each of the interface. For each of them, you can specify the IP address, the subnet mask, the type, and you can even write a short description. So a description for the interface as well. Now, the no shutdown command basically turns on the port or the interface. Okay. If you don't write the no shutdown, the interfaces on the router will not become green in packet tracer. They will always stay red. Okay. Now, if you are connecting two routers together, you will use a serial cable basically. One end of the serial cable will be DCE, right? The router that has the DCE end of the cable, you need to issue the clockrate command for that. Again, we will look at how to write those commands. It's something like clock space rate and then the number that they give you. Again, this should be set on the interface. Now, after entering the basic configuration, you should basically verify the configuration and the operations, and then save the changes on the router in the configuration file, so that the next time the router is turned on, it can keep all of those settings in place. Now, if you remember from the previous unit, the WAN connections, or the connection between the router, are made using the serial cable, which is the DCE cable. One end of the cable is DCE, and the cable looks something like this, and the other end is DTE, which it looks something like this. Okay. Now, DCE is where the clock rate will be. So if this end of the router has the DCE cable, this router is where you would set the clock rate. Okay. And the DTE does not require any clock rate. Okay. Now, what is clocking? If you remember from the previous unit, clocking is nothing but agreeing, or an agreement between the two routers as to when they will communicate and when they will not communicate. So basically, the time that the communication will take place between the routers and the time it will not take place, the time that the communication will not be there. So just think of it this way. If you are writing down something and someone is dictating it to you, so someone is saying something and you're writing it down, if they don't give you time to write it, then, as in, if they only keep speaking, then it is very difficult for you to write or to catch up, right? So, what usually people do is they will say something, they will take a pause, and the other person will keep it writing it down. Then the first person will again start saying something, and the other person will write it down. So that's the clock rate. So you talk, then you stop talking, you talk again, and then you stop talking. So the listener can listen. Okay. In this case, DTE is basically your listener or the receiver, and DCE on both ends is basically the supplier or the one that's providing the clocking. Okay. Now, DTE is usually on the customer's end. So, us as customers, we have the DTE end, and the DCE is basically from the ISP or from the provider. Okay. Just remember, clock time is when the two routers will communicate and when they will stop the communication. So, the timing of when they will communicate and when this communication will end. Okay. Now, configure serial interfaces. DCE needs clock rate. This is what I just said. So if you have the DCE end of the cable, it would need the clock rate. How do you set the clock rate? First of all, you would configure terminal. Okay. Then you would go to that particular interface. So in this case, we're going to serial port. So one of these serial ports here. Yeah, one of these serial ports here. You will go to one of them. I'm not sure which one is which one, but in this case, it will go to one of the serial ports and it will assign the IP address this, and this is the subnet mask. And after that, you're also providing the clock rate, indicating that this router is basically the provider or the DCE end. The no shutdown will turn on the port or the interface, and the exit just exits from the interface. So you need to enter the interface first, set up all these things on the interface, and then exit once you're done. Okay. If this was the DTE end, you wouldn't need to write the clock rate command. Okay. Routers and the network layer. So routers, basically they use the destination IP to forward the packets. So basically, like any forwarding or any parcel delivery service as well, you need to know the destination. You know, if you don't know the destination, you don't know where to basically deliver that parcel, right? So similarly, routers use the destination IP to figure out where the IP needs to be sent. Okay. But then why does it look at the destination IP? So basically, a router has something called the routing table. Okay. And it keeps track of all the networks that it knows of. Okay. Or that it can connect to. So let's say it can connect to 192.168.1.0, then 192.168.2.0, and then 192.168.3.0. So this particular router knows about this network, this network, and this network. So all the devices connected to these networks. This is the use of routing table, to know what networks this particular router can forward to. This is just like when you go to an airport, not an airport, but like you book a ticket or you book a flight with an airline. An airline can only go to so many countries. Maybe there's a airline that doesn't go to X country. Okay. It's because it doesn't know the route. So basically, a routing table is to figure out the routes the router can take or the router can forward the packets to. Okay. Now, After looking, so basically the first thing is it looks at the destination IP. It says, okay, which network does this destination IP belong to? Let's say it belongs to 2.0. Then for 2.0, it figures out the best path that the packet can take. Okay, so it figures out a path that the packet can take, and then it sends that the packet to that uh, particular path. Okay, now to send the packet, it needs to be converted to frame. If you remember, some people fear birthdays. If you remember this thing, it is segment, packets, frame, and then bits. So if we were looking at the packet, right? So if it wants to now move on to the network, it needs to be converted to a frame. Okay, and then after the frame, it needs to be converted to bits to basically travel across the network. So after packet, it's converted to frame, and then from frame, it's converted to bits, and then frame is placed on the network medium as bits. So you can just remember this as something like this: some people fear birthdays. I don't know if it makes sense, but just to remember it. So some is basically segment, people packet, year is frame, and birthday is bits. This is just to remember the first letter, so you can keep track of them like that. So basically what happens, you have a destination IP address, the source IP address, other fields, other data as well. The routers check the destination IP address, they figure out the network where it needs to go, and once they find out the best path for that network, the packet is converted to a frame to be moved onto that particular network, and then from frame it gets converted to bits to basically travel on the network, because everything that travels on the network is in bits, ones and zeros, right? Now when sending from PC1 to PC2, how many interfaces would the packet go through? So basically there's an interface or a port here, there's an interface port here, there's an interface or port here, interface port here, all of those. So again, interface port, interface port, interface port, interface port. So these are the ports that it would go through, right? So from PC1 fast Ethernet, it would also go towards the switch, but they didn't mention the fast Ethernet. They didn't mention the port, so we don't talk about it. So from PC, it would go to fast Ethernet 00 on the router. Okay. And then from router serial port, it would go to the serial port of router 2. And from there, it would go to the port FA00 on router 2, which will then be connected to PC to fast Ethernet. So basically 1, 2, 3, 4, 5, and then 6. Okay. So those many interfaces it needs to travel through. And we're talking about the packet. So there's a packet here, basically. This packet will first move to this particular interface. This particular interface. From here, it will go to the router. From router, it will go to the serial cables, and through there, it will reach the final PC2. Okay. Now, if we talk about the subnets that it needs to pass through, this particular network is in subnet 192.168.1.0. This connection is in the subnet 192.168.2.0. And then this particular network is in, or connections are in 3.0. Okay. So basically you have 3 subnets that a packet from PC1 needs to pass through to get to PC2. Okay. So this is your first network, second, and then third. Okay. Now, let's look at the fact as if router 1 can reach 192.168.3.0. If on router 1 you issue the command show IP route, It will show you the networks that this particular router is connected to. In this case, it's connected to 1.0, which is this network here. Okay. And then the second one is 2.0, which is basically this network here. Okay. Why does it know about this? Because of these cablings. Because it's connected through these cablings. That's why it knows that it is connected to this network address and this network address. And by the way, it calculates the network address by itself. Okay. So this is automatic. So it knows that it is connected to these two networks. But the question is, can router 1 reach subnet this with this IP address? It cannot, because it's not directly connected, right? So it doesn't know about it. The routers only know about the things that they are connected to, or the networks that you manually add to the table. But if it's only through connections, the routers only know about the addresses or the networks that are connected to the router. And if it's and this network is not connected to the router. So in this case, router 1 doesn't know about a 192.168.3.0. Okay, so what are we going to do? We're going to add a static route. Okay, this is the same thing. The router 1 doesn't know about this network because it's not in the routing table, because it is not directly connected to it. Now, okay, you can do two things about this. You can add a static route, or you can add a dynamic route. We will be focused on static route for now. Okay, you have two ways to resolve that issue, where router 1 doesn't know about this subnet. If router 1 doesn't know about this subnet, this PC cannot communicate with this PC, because this router eventually doesn't know where to forward the packet, right? So how do we make this router aware of this subnet? There are two ways. You can either add a static route, or you can add a dynamic route. Okay, this is a static route. On the router, you will go to the global configuration mode and you will type IP space route, the network address that you're trying to route to, along with its subnet mask and the IP address or the exit interface. Okay. Now, what are each of these? Network address is basically the network address of the network that you're trying to connect to. Okay. Subnet mask is again the subnet mask that belongs to that network. IP address is the next hop router's IP address. We will talk about this in a minute. And then exit interface is the outgoing interface that is used to forward packets to the destination network. Again, I will show this to you in a minute. Now, considering this network, okay, we said that this router R1 is basically aware of this subnet and this subnet, and it doesn't know about this subnet. Okay, so what we need to do is we need to make this router aware about this subnet. Okay, so you on this particular router, you will issue the command IP route 192.168.3.0. That is the network we're trying to identify and add to the routing table, along with its subnet mask. We're assuming that this subnet mask, if you notice here, it's /24, right? That means you need to have 24 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. This, if you translate it to decimal, it's 255, 255, 255, and 0. That's why we added the subnet mask 255 here. So now you understand this is the address that you are trying to find, or the network that you're trying to find or trying to add to your router, along with its subnet mask. This IP address is usually the IP address of the next hop. Okay, what does that mean? Now we're configuring all of this here on this router, right? The next hop is basically the next device. The next device after this network is basically R2, right? So you need to add the IP address that is assigned on this particular interface. You need to add it here. So we know it is .2, right? 192.168.2.2. That is the address. So this will be the address of that you will add here. Again, the next device to the network, to the router after the network is basically R2 here, okay? The interface that's connected between R1 and R2, you will take the IP address that is on R2. In this case, it is .2, which means nothing but 192.168.2.2, okay? So that means that that's the next place the packet can go. So basically, if the packet arrives here and it needs to go to this network, I need to first send it to basically this router, right? And then if there is another router, it would send it to another router, right? So this packet should go to the next router, and then from there on, that router will take the responsibility of forwarding it, okay? This is one way of writing it. The other way is basically you just write IP route, okay? And then, the same network address along with the subnet mask. But instead of the next hop IP address, you can put the interface that is the exit interface. So here, the exit interface for the router, meaning the one that's connected to the router that you're configuring, is S0000. So that interface, you can write it here, which would mean that the IP address should be sent out from this interface. So not the IP address, sorry, the packet need to be sent out from this particular interface. Okay, so the packet would arrive here, okay, and then it will see, okay, it is destined for 192.168.3.3, let's say. So it will say, oh, it belongs to the network 3.0. So send it to the interface serial 000, and from there it will go to the other router, and then the other router will figure out where to send it. Okay, so you have two ways. You can either write it with the next hop IP address or the interface, whichever one you feel fine. But usually in the question, it will be mentioned which one you need to add. Okay. Now, once you issue that command and you check the routing table, again using the show IP route, you will see that there's another record which is denoted by S for the network that we just wrote, and yeah, S just signifies that it is static. So you will see that there's a static route, and these are two connected routes. Okay, now when you try to send a packet from this PC, it will arrive to the router. The router will check the table. It will say, oh, it belongs to the destination. If the destination IP belongs to this particular PC, it will say, oh, it belongs to the network 3.0. So send it to 192.168.2.2, which is basically this interface. So the router will forward that packet here, and this router already knows about this network because it's connected to it, right? So it will then send it to that particular PC. That's how the communication will work. Now, static routes are added by the administrator of the network, so they're added manually, okay? And if there are many routers on your network, you will need to add many static routes. So that's the disadvantage of using the static route. You have to add it manually, and if there are many routers, let's say there are 10 routers on your network, you need to add all those routes there, okay? Again, like I said, it is denoted by the character or symbol S in the routing table. So this is nothing but when you need to use the static routes, okay? You should use static routes when you have few routers, let's say 2, 3, the like less number of routers. Okay. Or you have a network that is connected to internet only through one ISP. So basically you have a network here of routers, switches, all of those, and then it is connected to one ISP. Okay. In this case, you can use a static route, or in a case where you have few routers, let's say 3 routers, I would say. Yeah, 3 routers that are connected together. In that case, so when you have few routers, or you have one router, or your whole network is just connected to one ISP. Sorry, is connected to only is connected to internet through only one ISP. Okay. This is where you will complete lab 1.5.1. I will have a video on this. Don't worry about that. And yeah, that's about it. We will move on now. So summary, you have summarizing routes that basically reduce the space of the routing table, and then route summarization is the process of combining a number of static routes into a single static route. So basically, instead of having multiple records, you can have one static route that can combine multiple static routes together. Okay. And then you have dynamic protocols that are used to add networks to a routing table, which is like you set up a protocol that can automatically add the routes to the routing table, and it can automatically even discover new networks. So if another network has joined your network, it can automatically identify it and update the routing tables accordingly. Then there is automatic network discovery. Are able to, this is what I just said, so routers basically share information about routing table so that they can have automatically discover new networks that are there on the network. Again, all of this is in great detail later on. Some of this might not make sense to you right now, but that's totally fine, because we'll slowly start learning about these things little by little at a time. So maintaining routing tables. Now, dynamic routing protocols are used to share routing information with other routers and to maintain and update their own routing table. So you have different, basically the idea is that you set some protocols on the network, on the router, and it can belong to it can be any one of them. You can set those protocols, and what the routers will start doing is they will automatically start sharing their routing tables with other routers. And when they share their routing tables with other routers, they will see, okay, this, for example, let's say this router shares its routing table with this router. Okay, and this router has access to this network, this new network as well. But this router doesn't know about that network because it's only connected to this network and this network. So when these two routers basically share their routing tables, this router will see, oh, this router 2 knows about this particular network as well. So it will add that network to its own routing table as well. Similarly, on the other end, if router 2 doesn't know about this particular network, then by sharing the routing table, it will see that, okay, router 1 knows about this particular address, so it will add it to its routing table. Okay, this is again dynamic routing protocols. All of this, there is separate chapters on all of this, so don't worry if this doesn't right away make sense to you. Now, router paths and packet switching. Now, path determination is a process used by a router to pick the best path to a destination. Okay, so what routers do is when they get a packet, they try to figure out the best path that they can take, that the packets can take to reach its destination. Okay, when figuring out the path, the network could be directly connected. So let's say the router is directly connected to the network where this PC is trying to send a packet. Or it could be on a remote network, which means it is connected to some other router somewhere else, and the packet needs to be transferred there. In that case, it would become a remote network. Let's say this PC wants to communicate with this PC. In this case, it would be direct. Okay, but if this PC here wants to communicate with this PC, it will become remote because it's away, and this router doesn't know anything about that PC, or it's not directly connected to it. So that's the second one. And the third one is no route determined, in the case when the packet that is sent or the PC is trying to communicate to on an IP address that is not present, or the router doesn't know about it. So that will result in a failure. Switching function of a router. So basically this is a router. Okay. Now it is connected to, let's say, a computer or a switch, let's say a switch, and then it's connected to a PC. Now the PC sends some packets, they reach the router. They reach on the incoming port. Okay. The switching function is the process that the router tries to figure out the not the destination, but the router tries to find out where this incoming packet needs to exit from the router. So there's an outgoing port or outgoing interface on the router, and there's an incoming interface on the router as well. The router figures out, the switching function is basically figuring out from the packets that are on the incoming port, where should they be sent out on the outgoing port. And all of this happens on the same router. So basically, when you receive a packet on a router, it strips off layer 2 headers. So if we remember, there are 7 layers, right? So layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, layer 1. So when you receive packets, they come in the form of bits. Okay. Then they have a frame. Then there is packet. Then there is segment. Okay. The remaining is just for application layer. But okay, when you receive the fragment, when you receive the frame, you need to remove the data that was added for the frame layer. When you remove it, you will get the packet, and that's what routers use to examine. Okay, so once you get the packet, you will look at the IP address that is located in the header to find the destination. So within this packet, there will be an IP address for the destination. The router will look at that IP address and figure out where it should be sent. Then it re-encapsulates layer 3 packet. Once it figures out everything, where it needs to go and all of that, then it adds the frames data again, and then it's converted to bits to again move through the network. Okay, and then it forwards frame out exit interface. Basically, it receives a frame. It removes the unwanted data to get the packet. Okay. Once it gets the packet, it looks at the IP address that is stored in the packet to figure out where it should be sent. Once it figures out where it should be sent, it adds the same frame data again to the packet to then move it across the network again. Okay, that's the basic idea. Now, routers are basically to send data over a network, so over inter-network devices. So inter-network meaning devices on different networks. We saw that routers have CPU, memory. We didn't talk about this, but they have all of these. They have configuration files. Router needs to be configured. You need to configure the router to basically use it, otherwise it's useless. You need to set the name, banner, passwords, and interface configurations. These are important and they are best practices. And routing table contains information about directly connected networks, remotely connected networks, networks and addresses and subnet addresses, which are static probably, and the address of the next hop that is connected to it. So all of this is was discussed in this unit. Uh, Again, we spoke about how routers basically find the what's it called, the destination and where to forward the packets. And we also looked at the WAN and LAN connections. These are basically serial ports and these are Ethernet ports, and they have different functionalities and features. So that's about it for today. I hope it was understandable. Um, Basically, you need to understand routing table, static route, and how the routing basically works, how the routers are able to find the best destination. They look at the IP address. First of all, they take the frame, they look at the IP address, they put the frame back, and they send it over the network. That's how it works. Uh, Go through it again. Again, I will post the lab activities as well. I will record videos for those as well. Let me know if you have any questions, and have a wonderful day.